Welcome everyone. I guess we'll get started. I hope we're all having a good day. Everyone's staying safe. Thank you for joining me today. The focus of this presentation is on using GEOB 3D confinement for port intermodal facilities. I'd like to thank you all for taking time out to attend. A little about myself. I've been with Presto for a little over 12 years now. Prior to joining Presto, I was an engineering consultant for over 20 years, focusing on all different types of civil and geotechnical projects. I'm active member of AREBA Committees 1 and 5. I'm also a member of ASTM D18, Soil and Rock, and also ASTM D35, Geosynthetics. So here are the things I hope you get out of today's presentation. Understand the benefits of using GEO for soil stabilization, including the ability to use low-quality fill, recycled materials, and even sand. How the system reduces vertical pressures and subbase movement, and finally how 3D confinement can reduce pavement depths while extending pavement life, along with reducing maintenance and providing a more stable base. During the presentation, if you have any questions, you can just please type them in the chat window, and we can address them at the end of the presentation. So a little about Presto. Presto, we worked with the Army Corps of Engineers to develop geocell technology in the late 70s. We continue to be the leader in innovation. We offer more than just a product. We work with all of our customers from initial concept phase through construction to support a successful project. We have a worldwide distribution network, experienced not only in geocell technology, but other geosynthetics as well. So our assistance does not stop when a product leaves our door. We operate in 4 product areas using our geocells, which can be used for load support, which we'll focus on today, slope and channel protecting, and constructing green retaining walls. Porous pavements, which we have both vegetated and aggregate solutions, and lightweight reusable construction mats. I will, at the end of the presentation, I do have a couple of slides on slope protection. A lot of ports and intermodal yards, we are doing some slope protection as well. So let's begin with discussing how GEO 3D confinement can provide benefits for unpaved and paved surfaces. The GEOB system consists of 2 main attributes. The first is the cell size. The cells come in 3 different diameters, 8.5, 10.5, and 18 inches. The cell wall heights include 3, 4, 6, 8, and 12 inches. The actual cell size and height will depend on your site-specific project details and site conditions. Presto will provide a free evaluation, including calculations, cross-sections, and specifications for free. And this is no matter how big the project is. The ultrasonically welded seam, where all the connecting points are located, is very important to the function of a geocell. The stronger the seam strength, the better performance of the geocell, period. And a strong seam allows for better lifetime performance. GEOB is produced using high-quality, virgin, high-density polyethylene resin for consistently strong welds at the seams, while also maintaining semi-rigid ductile properties, high stress crack resistance, overall toughness, and long-term durability. GEOB geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce weld strength. And there are often some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity and performance across all elements of a geocell system is much more important than stiffness alone. Here you can see a typical GEOB panel. It comes tri-folded on a pallet. Each panel here you can see about 8.5 feet in length. And we do have different lengths depending on what size you need for your project. Panels are very flexible. You can see they expand very easily for installation. In order for a geocell system to perform uniformly, it is critical that both the factory welded junctions, those are the internal junctions, and field joint junctions that connect the individual panels, the mechanical junctions, perform at a level that is the same with that of cell walls. Therefore, an incremental improvement in one characteristic, for example, cell wall stiffness, is only valuable if a complementary improvement has been made in the other components of the system. Like I said, GEOB manufactures a proprietary blend of high-quality virgin HDP. Our proprietary formula has stood the test of time for more than 40 years and contains no fillers, unstable polymer combination, or exotic polymer alloys. For most typical sites, GEOB retains durability for greater than 50 years, with lab tests indicating 140 years without degradation, even at full exposure to the elements. We stand behind our numbers so you can deliver certainty in the solution you build with materials you can trust. The system components are all the supporting pieces that help the GEOB protect the surface and sub-base layers. It also ensures relatively uniform performance of the interconnected system, thereby protecting against the damaging effects of non-uniform deformation and differential settlement in response to applied loads. First, the GEOB is equipped with numerous design and construction components that increase the strength and speed of installation. For load support applications, the AttraKey is a major component for a completely integrated system. AttraKeys connect GEOB panels into a single system. The key's speed installation are made out of plastic and will last the lifetime of the project. AttraKeys ensure that the panels will not separate, and that the GEOB system will not fail under anticipated loads. The specific engineering values of the AttraKey will ensure the system holds up to loading over time without the corrosion seen in staples or the failure underperforming zip tie systems. Here you can see the slide how the AttraKey goes through an eye slot in the cell wall, connecting the adjacent panels. The purpose of cellular confinement is very simple. It's to stabilize the movement of unstable soils, both horizontally and vertically. It is an engineered system integrating multiple geosynthetics with the best method of confinement and subgrade stress reduction. Here's a typical cross-section for load support application. We start with the subbase of varying strength, typically expressed as a CBR. Then we decide if we need a geotextile, whether that's an enhanced woven geotextile or a non-woven geotextile. The type of geotextile that we use is basically based on the subgrade strength. Do we need more reinforcement? Do we need to go with like an enhanced woven that has, strength pounds per foot? Do we have a lot of fines where the fines could get into the non-woven geotextile and clog it? So all those factors come into play when we're designing a system. Based on the design that we'll give for free, sometimes you may need a subbase under the GEOB, especially if you got poor CBRs. Then the GEOB system is placed and with the desired infill material. Like I said, that could vary. We can use sand, coarse sand, we can use crushed aggregate, recycled materials. It will have a surface course and that supports the given load. So GEOB 3D confinement works this way. When a vertical load is applied, the active earth pressure in the load itself pushes back against the passive earth pressure in the adjacent cell to form a stable system. So each cell helps support the ones around it. The GEOB cell walls also transfer hoop stress, which is important in keeping the system intact and creates what is known as the mattress effect. The strength of the seams around each cell, the material stiffness of the individual strips, and the connection method between panels are all important factors in determining how the GEOB system can improve site condition. Strong seams, semi-ductile resin properties, and integrated connections are critical to the performance of the system. In a low support scenario, as we know, vertical deformation can only occur with compaction or through lateral movement. By spreading out the load in the classic approach, one can reduce compaction on your surface cells, but only with cellular confinement and ensure that no lateral shifting and rutting occurs. Here you can see the stresses on the subgrade with the unsupported subgrade on the left and the GEOB reinforcement on the right. Notice how there's a complete elimination of the highest stresses at the surface with the GEOB reinforcement. The stresses are reduced and distributed over a wider area, which once again we call the mattress effect. This effect reduces stress reaching the subgrade and leads to a significant decrease in deflection and rutting. The second main attribute of the GEOB system is the infill. The important benefit of the GEOB system is that even a low quality aggregate, recycled materials such as crushed concrete, and even sand can be used to infill the cells. Using recycled materials, low quality aggregates or sand you can imagine can save a significant amount of money, not only on the material, but also in the hauling costs. We can also eliminate fines when desired, since the cell walls provide the confinement and aid compaction and cohesion of the soils. So without fines, you can significantly improve drainage and let the water flow freely through the system, preventing pore pressure buildup and ultimately global failure. The ability to use sands and low-quality aggregates really sets geode apart from other geosynthetics, which need a high-quality aggregate. Those products require high-quality crushed aggregates, high friction angles to achieve performance. With the geode system, low friction angle materials are just fine. The geode panels achieve their full potential even with these poor materials, which can be a huge savings. Here you can see the impressive load benefits of an 80,000 pound loaded dump truck. So an AASHTO H20 loading in a partially filled geode panel over a soft subgrade. You can see how the cells push back against each other to support the load, and only adjacent cells need to be filled for support. Another good thing about the geode is once you have this infilled, you can actually start using it as a haul road. It doesn't have to be compacted. Once it's filled, you can start using it as a haul road. So we now describe how geode works at the surface to create a stabilized, unpaved road. The aggregate surface has advantage in saving pavement costs. And with geode filled open grade gorse, like I said, you can provide some stormwater infiltration and storage. And also I'll show you a project for reducing stormwater volumes. Here's a typical problem in a materials handling yard: deep ruts over a soft subgrade. As the slide shows, rutting develops due to the lack of confinement and pushing and shoving of the base material. This project was rushed because the railroad purchased a 100-ton reach stacker without understanding if the subgrade would support the intended loadings, and the facility was scheduled to start operation within a few days. The loader made only a few initial passes before the weak subgrade started to fail. Deep rutting caused concern, not only for the integrity of the surface, but also for safety. We worked the client. This was actually really close to our shop. This was done probably about 20 miles from our plant in Wisconsin. Here we use 8-inch geode panels on top of a 12-ounce non-woven geotextile. This was put in 25 years ago, and it's still in operation today. Here you can see the final solution with the geode reinforced section supporting load with no rutting and reflection. Note the cross-section diagram where you see basically we have a 8-inch geocell with the non-woven geotextile and a 3-inch surface layer. This is the intermodal project for CSX Railroad in South Carolina. As you can see in the picture, the 60-ton reach stacker was severely rutting the existing aggregate yard. The rutting led to slowing down of loading and unloading containers, along with routine maintenance was required to keep the yard in operation. The subgrade wasn't that bad. It was around about a 2% CBR, but there were so many fines in it that that's what was leading to the rutting. And here you can see a close-up of the rutting that was occurring. We worked closely with the engineer and CSX to come up with a system to support the load and eliminate rutting. We worked closely with the geotech and the owner on this site, and through the review of the report, it was determined that we could use the on-site fill to be used for the geode panels. So this significantly reduced the cost of importing, cost-free aggregate fill. Here the solution consisted of, once again, 6-inch geode panels, enhanced woven geotextile, and a 4-inch wear surface. Here you can see the geode panels being filled with the on-site soils. The contractor basically just stripped off the material down to the desired elevation of the subgrade. You can see on the side, they just stockpiled it on the side and then transferred material back into the geode panels as the infill. So once again, it's limited need to import costly fill. But one of the biggest savings is that the downtime of the yard was significantly reduced, which was especially important due to the high volume of tractor trailers that the facility handles on a daily basis. And here you can see the final solution. Like I said, we filled this one up with sand, the existing site soils, and then we came in with 3 to 4 inches of a crushed aggregate, just as the wearing surface. This project was started out in Mexico. The original design called for a reinforced concrete surface, but all the bids came in well over budget. So the client looked at different solutions and some value engineered opportunities. Once again, this wasn't that bad. It was a 3% CBR. Once we worked closely with the engineer, come up with a system to support the 80-ton reach stackers. So this one, once again, the design consisted of an enhanced woven geotextile, 6-inch geo panels, and a 4-inch wear surface. This one, they used a really low quality crushed aggregate sandy fill that they had around the site. Here you can see the panels being infilled with the infill material. Here the fines content we limited to about 15% to allow stormwater storage too, infiltration. This photo is also good at illustrating how infilling can be accomplished. The trucks just dump the aggregate into large piles. Then either with the front end loader, a dozer or any similar equipment, the aggregate can be pushed into the empty cells while the equipment drives on the filled areas. So it's a very fast and efficient process. It doesn't take any additional training or expertise on behalf of contractors. You can see the final wear surface being applied over a solid surface. After placement on this one, they actually had a little small asphalt tack coat as a surface just to control dust, provide a little extra strength. This was an interesting project as the GF solved 2 issues. This was a 2-acre site in Pennsylvania where the owner wanted to increase the size of the facility, but there was not enough room to provide a paved surface due to lack of area to increase the stormwater ponds. The first issue was to provide a durable driving surface over a poor subgrade for parking and storage areas along with area of expansion. So existing service on this one would require maintenance on a routine basis due to the poor subgrade and heavy loadings. The area had to support AASHTO H20 loadings, also along with the heavy loadings from the wheel gantry cranes. So through the design process, we came up with a solution for him. We actually had a geotextile went down, a heavyweight non-woven geotextile. This one we had a 4-inch base, 6-inch geob, and then a 3-inch wear surface applied. The second issue was to provide on-site stormwater or on-site water storage to allow the facility to reduce the volume of water reaching your stormwater pond. As I mentioned, since you don't need fines to achieve compaction with the geob, the system will act as an on-site detention basin, storing water in the void spaces of the fill. As a general rule of thumb, a 3/4 crushed aggregate has a void space of approximately 35%. So you can imagine how much water you can store potentially to reduce stormwater runoff and ultimately the ability to reduce the stormwater pond volume. Since the local stormwater municipality let us store water inside the geosystem, it allowed for the expansion of this facility, and the existing stormwater pond did not have to be increased. You can see a close picture of the open grade material that was used. No fines, good for lockup. One point on geob compaction, there's no need to really, hammer the infill with vibration to achieve compaction. Typically, vibration is kept low and the weight of the compactor is more than adequate to provide proper compaction. If you try to really vibrate the material, you can actually lift the geob panel. So just be aware that you should just lightly vibrate or just typically roll it. And here you can see this facility was installed in 2001. You can see the picture on the left. And in 2011, no running has occurred, minimal maintenance. This facility is still in use 20 years later. The geob is still in place. We do port and intermodal works all over the world. This is a geob surface stabilization system for phase 3 at the port of Invergordon in the UK. The project was for 6 acres. It consisted of 2 separate areas. One area was 3.5 acres and used 4-inch deep geob panels, and the second area was 2.5 acres and used 6-inch deep geob panels. The 2 areas were subject to different loading conditions, and during the design phase, we worked with a consultant to determine the most appropriate panel depth to meet site conditions and still provide a cost-effective solution. The 4-inch deep geob panels was used in the vehicle parking and storage areas, and the 6-inch was used where the gantry cranes were. The area was constructed using unbound pavement with a crushed gravel surface. The geob presented the perfect solution to minimize the overall cross-section depth through its load transfer mechanism while controlling differential settlement in the heavy loaded gantry crane area. Differential settlement was a significant concern on this project due to the variable subgrade strengths. So the engineer developed a cross-section that would bridge low subgrade CDR areas and use and enhance 70 kilonewton per meter enhanced woven geotextile along with the geob. One of the most cost-effective methods to reduce long-term consolidation from settlement due to cyclical loadings on a soft subgrade is to increase the stiffness of the overlying area. So here, under cyclical loadings for all these projects, GEO prevents the lateral movement of the infill material and dramatically increases the shear resistance. So in effect, PVA is more like a three-dimensional structure or semi-rigid slab. The high shear strength and greater load distribution reduces the vertical stresses reaching the subgrade. So the end result will be a more durable subgrade that will increase pavement life, preventing long-term settlement and consolidation. And once again, here they're just lightly compacting it, no vibration. Here you can see the final surface after compaction. I said this was about almost 6 acres and a 2% CBR. It doesn't matter how small the project is in size, and we always provide the same amount of technical support in our evaluations, including cross sections, calculations, specifications, and a written summary. Here's a project for gantry craneways being used to unload trailers from rail cars. You can see there's a significant amount of running due to the crane and the interesting methods used to stop the running. They tried metal panels and even timber mats with no lock. We do a lot of work with this Class 1 railroad. So the Class 1 that operates this track told the owner to give us a call since it was taking so long to offload the rail cars. Like I mentioned, it was not a variant project. You only used 15 panels of GEO on each side of the track, but we still provided a full evaluation. So the owner and engineer completely understood our solution and its benefits. This one, the solution consisted of a heavyweight non-woven geotextile, 8-inch GEO, and a 4-inch wear surface. As mentioned, we provide free evaluation of all projects, no matter the size. So the evaluation, like I mentioned, will include the written summary, cross sections, calculations, and specifications. Typical turnaround time is 1 to 2 days, and we'll provide full details of the calcs used to prepare the evaluation, so you have a complete understanding of how we did the calculations for all of our projects. Typical turnaround, 1 to 2 days. If we have questions, we'll give you a call and work those out. So now we discussed how GEO is beneficial in our hard pavements, including asphalt, reinforced concrete, and roller compacted concrete, and especially in areas with soft subgrades and drainage issues. We can all relate to this slide and recognize the problem. An unstable base under hard pavements, over time will lead to rutting, settlement, potholes, degradation, and eventually complete failure. Common factors include, differential, localized sediment, soft subgrades, poor drainage, reducing the damaging effects of differential settlement and protecting against buildup of excess pore pressures are key factors in extending pavement life and reducing long-term maintenance costs. This project was for Union Pacific Railroad in San Francisco. It is an auto storage yard for cars being offloaded from Korea. The original design included geogrids with a high-quality aggregate. When construction started, the subgrade was too wet and too soft for geogrids to be a cost-effective solution. So the engineer contacted us to provide a value engineer solution using geodes. For GEO, this area has some very low subgrade strength. CBR is 1% or less. You can see the pictures how mucky it is. So we worked closely with the engineer and the railroad to provide a GEO solution. Consisted of a high strength woven geotextile, 6-inch base layer, 6-inch GEO panels, and then a 2-inch wear surface over the top. And then ultimately it was paved with asphalt. They put the base layer, this base layer here underneath the GEO to function, 2 different functions. One was some extra stability, some extra strength, but also we kept this layer here low fines and allowed the water to flow freely under the pavement so it didn't build up the pore pressure. You can see the expanded GEO panels and open grade infill being placed into the panels. Here they just dumped them and they used dozers and front end loaders with the GPS system to get the proper elevation. Just a close review of the infill procedure. Once again, aggregate is just dumped and pushed into the cells. Most commonly now just with the GPS system on top of the dozer. Once the cells are filled, you can immediately drive on it without compaction. Very quick to install. You can see the GEO panels are always far out ahead of the infilling. You can see the placement of the asphalt on top of the GEO panels and the wear surface. Regular asphalt paver was used. It's compacted with smooth barrel roller. No special equipment or procedures are required when paving over the GEO panels. so paving crew can install it at regular speed without needing extra training or additional equipment of any kind. This is another auto storage yard. This was for BNSF. Oh, before I forget, this one, the Union Pacific, we're actually just are finishing up our third phase of this project. We're doing another, I think it's 7 acres this year. So it's a pretty big site. Yeah, this is another auto storage yard for BNSF. It's by the Seattle International Airport. This was a 20-acre site, subgrade strength ranging once you get from 1 to 3% CBR. The original design included 2 layers of geogrids. After bidding, the cost came in higher than the budget allowed. So the engineer contacted us and we did a valued engineer solution. The cost came in extremely high because the aggregates were very expensive. They had to be hauled from basically right through downtown Seattle. So it wasn't a very good use for high quality aggregate. It was determined when we met with the engineer that we could actually use on-site soils mixed with the gravel. So we saved a significant amount of material costs, but also sped up construction time. Staging is very important for any project. We have a significant amount of installation experience, and we will be on site to support the contractor with tips for quick and efficient installation methods. Here you can see the use of staging tables, where adjacent panels are just connected together with the Attica prior to being expanded and placed across the prepared subgrade. Each of our standard panels has an area of about 230 square feet. And this contractor is using the staging tables to connect 3 panels, which provides an area of almost 700 square feet. So you can allow the workers to stand up while connecting the panels. So it goes a lot faster, a lot more efficient. Then the panels are just transferred over and connected to the panels that are already in place. Typical installation rates, when they start, they'll be a little slower, sort of like hanging drywall. You want to install the first couple panels so they're straight. But once you get going, at least 3,000 square feet an hour with a crew of 3 people. This contractor wanted really square panels for the entire installation. So actually survey staked each corner of every panel over the 25-acre site. So once the geo panels were filled, they just went ahead and pulled the stakes. You can see each of those. This would be lengthwise, 27 feet in length, 8.5 feet in width. And here you can see a picture of the site with the installation ongoing, 4-inch wear surface to allow for access. You can see the stockpile soils over here. The dump truck once again is back up to the geo, dumping info. This one you can see spreading with the bulldozer. He has a bulldozer with the GPS system. It's right here. It goes very fast. And here's the finished service. This is a project for a port in Latin America. Served as a coal and container storage. Consisted of an access road in the storage area. Subgrade had a very low CBR, and the owner contacted us for help to provide a base solution for an access road and storage. We worked closely with the engineer once again to provide a complete solution. Once again, we used a enhanced woven geotextile, 6-inch geo panels, but was filled with a local fill, sandy aggregate fill. Like I said, you can see when they're filling them, they're just driving right across the uncompacted cells. And after placement, it's ready for compaction. Once again, you don't have to vibrate it very hard. Just overfill it and compact it. Here's the final surface before the asphalt layer is placed. You can see this installation tape. Packed it to the top of the geo panel. They had no overfill, which is acceptable, even if they do asphalt. If it's going to be, just an aggregate surface, we recommend a couple inches over the top of the compacted material. Here's the final access road to the port, showing the asphalt. This is a very interesting project we did. This was the Port of Panama. During excavation, the contractor actually encountered a very large area of petroleum contaminated soils. You can see here. They basically stopped the job. The options were limited, as you can imagine. The removal and offsite treatment and disposal costs would have been significant. So we actually met with, this was a old Air Force base, so it was a government-owned site. So we worked with the government, the engineer, the owner, to actually use this contaminated sand as infill for the geo panels. You can see all the existing, like I said, this Florida, we have a lot of these sands. These are always used for the geo infill. So they just took them, leveled the site, and then used to contaminate material and the clean material for infill for the geo. And you can see the laydown yard, enhanced woven geotextile, 6-inch geo panels. This one actually ended up with 6 inches of asphalt. Once again, we'll provide free evaluations for project geo under asphalt. We do use the ASTO method along with load equivalent factors and also based on geo research. And we can give you all those calculations. This project was a design build for Florida East Coast Railroad. In the overhead photo, you can see the gantry craneways. These are the gantry craneways that were used to offload the rail cars. The gantry crane was constructed with roller compacted concrete. The original ground improvement strategy called for 8 months of surcharge loading over most of the site to accelerate primary consolidation and protect against excessive settlement in the future. So not surprisingly, the long timeline to implement the preloading strategy was deemed unacceptable to the project owner. Since it was a design build, Presta was asked to be part of the team that come up with cost savings for base stabilization and long-term settlement concerns. So we worked closely with the engineer. The first ability that they say was to use sand infill to replace a specified 3/4-inch crushed limestone that would have to be imported to the site. The specified geogrid would have required to use a high-quality aggregate since the performance of the geogrid is directly related to the quality and the friction angle of the aggregate. The ability to use sand infill saves a significant amount of money at construction time. The second function was the ability of the geosystem to control short and long-term differential settlement to extend pavement life. So the geosystem behaves like a semi-rigid slab, as stated, to improve the load distribution and reduce vertical stresses reaching the subgrade, allowing for small amounts of uniform settlement. Since geo significantly reduced vertical stress reaching the subgrade, the end result is a more durable system with increased pavement life through controlling settlement. On this project, actually, it's been in for about 5 years now, and it has settled, but it's settled uniformly, and probably less than half of what the original settlement calculation showed. So here you can see once again, design consists of the high-strength woven geotextile, 6-inch geo panels, locally available sand fill, and actually an 8-inch cover. You see all the panels just being installed on top of that enhanced woven geotextile. So the combination of enhanced woven geotextile and the geo provides the system to control settlement, bridge areas of soft soil strength, and reduce consolidation settlement by significantly reducing the stress in the subgrade. And also, I should mention that when I'm talking about enhanced woven geotextiles, they're in the new ASTO manual and in the REMA manual. It's not a woven, it's a geotextile. Woven geotextile allows drainage, filtration, and reinforcement. It's not a woven slit tape. Split tapes are very low flow capabilities, and pore pressure can build up and actually lead to global failure of the cross section. These slit tapes have actually been removed from the REMA manual for the use of any load support applications. So I'm talking about enhanced woven geotextiles. Like I said, they provide drainage, filtration, and reinforcement. Here you can see the sand infill being placed in the cells, in addition to sand being compacted with a roller in the distance, allowing the kind of staggered work rather than having to finish each stage. Great way to reduce construction time. Installation of roller compacted concrete. RC pavement is pretty interesting. Wear surface is basically a low slump, high PSI concrete with no reinforcement. Typically goes down in lifts approaching 12 inches, becoming more popular around the world. Another important cost savings for the owner on this job is the original design consisted of 24 inches of RCC pavement. Like I said, it typically goes down to 10 to 12-inch lifts. We were able to, by reducing the stress on the subgrade, we were allowed to reduce the RCC thickness from 24 inches down to 18 inches. So you can imagine they save construction time and cost savings. Here you can see rapid replacement of the rollers that are on it, very durable surface. No maintenance in this place, no maintenance on this facility over 5 years. This is a project we did in the car last year. reporting a 7-acre area that needed upgrades to enable operation of the gantry cranes. The terminal needed base layer and surface stabilization with strong considerations for cost and timing. This was a design build project, and the Geo load support system offered the value engineering considerations and benefits such as a fast installation, reduced cost cross section, with no need to surcharge the area. The original plan was to provide site surcharging for 3 months. So Geo also allowed use of recycled on-site infill material, eliminating need for, they were originally going to do some chemical stabilization. So it saves some time and costs. This was, like I said, was a design build. With the COVID travel restrictions, on-site support was limited to basically our distributor in that area. But we have very detailed online webcasts, videos, and installation guides. We met with the teams, we met with the project owners via Teams. We have very useful website I'll show you at the end of the presentation. We have YouTube channel with hundreds of videos showing proper installation techniques. Of course, we typically have a rep on site with installation and training support. Here you can see contractor used a really low quality aggregate fill, mostly sand. You can see in the picture here, very low quality fill. And the final solution consisted of concrete pavers. 120 millimeter concrete pavers were installed over the Geo system. So this was the first 2.5 acres of the yard just installed before the rainy season. Had some heavy use installation with no settlement or maintenance needed. So even with the exceptional heavy rain and flooding that occurred. For this method, or for this type of design for the concrete pavers, we used the British Ports method for our designs. Once again, same thing with the hard surface pavement, whether it's concrete, road compacted concrete, or pavers, we provide a full design evaluation, including cross sections, calc specs, for the concrete pavers. Once again, we use the Astro method for asphalt and reinforced concrete. Road compacted concrete, we use the guide for compacted concrete from the National Concrete Pavement Center, and the British Ports method for the pavers. So in summary, Geo can be added to port intermodal project to provide a more stable and longer lasting service for unpaved areas, which reduce maintenance repairs, or paved surfaces, including asphalt, reinforced concrete, road compacted concrete. Geo decreases pressure in the subgrade to reduce differential and long-term settlement, which will extend pavement life and reduce maintenance. The ability to use low-quality aggregates, recycled materials, or even sand can save a significant amount of money. Also, the ability to reduce the stress in the subgrade, potentially reduce the final pavement thickness, leading to project savings. Once again, we provide the free evaluations for a complete solution. So the solution includes not only Geo, but also the geotextile type and strength, depth of the subbase, if required, and thickness of the wear surface or pavement layer. And I get this question a lot when we do these webinars: is why can you use sand? Geo was actually invented. I mentioned before, the U.S. Army Corps of Engineers in Presto developed the technology almost 40 years ago, and we developed it for sand infills. And it actually was called Sandburden for the first 10 years of its existence. So in a couple of minutes, I just want to go over some, we do a lot of slope protection on intermodal and port facilities. Geo for slope protection is a very flexible solution. We can use different types of infill depending on the project needs. We can use topsoil, and it can be vegetated surface. A lot of embankments, we do it with aggregate infill to reduce the need for any cutting and maintenance. We also use concrete in a project where no maintenance is desired, or areas subjected to heavy rains and high shear stresses. On this slope project in Montana, I was existing to a rail facility. Aggregate infill was chosen for nearly 200,000 square feet on 2 sides of the embankment for erosion control, but also they wanted a low maintenance slope cover. Here you can see the material is basically installed from the top of the slope down. Here you can see how the workers installing stake anchors to keep the Geo sections in place. Here you can see the panels being infilled with the crushed aggregate. Infill is done always from the top down to prevent panel overstretching. Here you can see these are 24-inch Atra stakes. Basically what it is a number 4 rebar, 24 inches in length with a little Atra stake clip on top. We do typically, especially on larger projects, you can see this guy using a Hilti hammer, a percussion hammer, just to drive in the anchors so you don't have to pound them in by hand. So we have a lot of other quick and efficient installation techniques that we have in our manuals and all of our guides. Just a close-up picture showing the panels being infilled, even infilled going under the bridge and the abutments. Here's a picture of the finished slope taken about 2 years after. We will actually size the type of infill you put in here on slopes. If it's an aggregate solution, we've done a lot of research on testing at the hydraulics lab at Colorado State. So we have a model that actually will size the aggregate and the depth of size and depth of the geopanel. This was a project, a new siding for Union Pacific in El Paso, Texas, of 450,000 square feet of 4-inch geode filled with crushed aggregate. This area does not get a lot of rain, but when it does, it typically gets a short and large burst. So UP has been using geode on these type of sidings to eliminate the need for any maintenance. You can see on this one, put down a woven, non-woven geotextile. We have a little anchor trench on top. You can see the panels prior to infill placement. Large riprap was spread on the bottom next to the culverts for extra protection. Here you can see the large culvert pipe on the rail. So you can imagine how much rain this area gets in the burst of that big of a culvert pipe. A very big area. Here's the intermodal project. We did this for Union Pacific down in Laredo, Texas. About almost 750,000 square feet of geo. The original design actually called for concrete, 6-inch reinforced concrete in the channel. This is the channel on top. And then they had basically ACB revetment mats going down the side of this thing. Due to the high bid costs, the contractor came to us about some value engineered solutions. So we came up with a solution using 3-inch deep geode panels on the slope, and 4-inch geode in the channels, and the crest replaced the reinforced concrete and the revetment mats. So basically we have 4-inch geode here and 3-inch geode on the slopes. The only reason we did 4-inch here was a little bit of extra stiffness because they had trucks that would come here and get out these settled material that were in the channel. You can see the concrete being placed inside the geode panels. You can see how far the geode protection extended around the yard. You can see also how the geode channel on top. So here's the geode channel on top extending all the way out around the yard, and then the 3-inch slope protection. This saved them a significant amount of dollars as far as construction. So we completely replaced all the formwork and the rebar and just used concrete, regular standard geode infill with concrete. So that provides the reinforcement and the strength and the formwork. So this facility got into service a lot quicker using geode versus traditional methods. So we have a very detailed website at www.prestogeo.com. Many tools available for your projects. We have quick links for information, for the design through construction, and a learning section actually here, where you can see hundreds of previous webinars. We also have a quick link to YouTube right here, where you can see hundreds and hundreds of videos. So it's located in the upper right of the website. So part of our complete solution is our technical assistance. As stated, we will provide you free of design evaluations. The form is on our website. You just go to it. Oops. You just click on here, get a free project evaluation. It'll open up a link where you fill out the information, and you can attach sales reports or any other pertinent information you think would help for us to do design. In 1 to 2 days, we'll get you a design back. And here's what the form looks like. Very easy to follow form. You just click on it. So very easy to form. If you don't know what the information, or I guess you don't have the information, that's fine. Just leave it blank. Like I said, if we have questions, we'll contact you. We have made it faster and easier for you to obtain. So if you watch in the learning section here of our dashboard, you can watch all the different webinars. We probably have 50, 60 webinars up there right now. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars completed along with the PDHs earned. So please note the live webinars are a little bit different. So we'll get you a PDH certificate in a couple days. If you not receive anything, please let us know. So I want to thank you so much for taking your time out today on your busy schedules. My contact information is listed here. And if any questions come up later, please reach out to us. As mentioned earlier, if you don't have enough information for fill evaluation, just call or contact us through our website. We have the best distributors around the world, and we can make sure you have the appropriate product to meet the project challenges. We know that GEOHUB is not the solution for all projects, so those distributors come in very, very handy. If you need to contact us, just go to our webinar, our web thing. Let's have a contact us. You click on that, and oops, here. Yeah, just go to contact here on our website. Click contact. All of our names will come up. Just click on our name, and you can send a question. So with that, like I said, I want to thank you. You have time for a couple questions. Oh, how long does the plastic last? So, since it's buried in the ground, it's going to basically last forever. I mean, we have tests of wall sections that we've done with basically we had carbon black to the material, so it doesn't degrade under UV light. We had HALS, which is a light stabilizer for walls. We have testing that GEOHUB exposed to 100% direct sunlight 24 hours a day. The additives in the cells will not start to degrade until 149 years. So it's pretty significant. I used to do a lot of landfill testing when I was a consultant, and it was amazing how much plastics that were in the ground for a long time looked like it never even aged at all. So it's chemically inert, so acids or bases shouldn't react with it that much. Typical installation rates, yeah, like I said, about 3,000 square feet an hour for a group of 3 guys, typically 2 guys connecting the panels and 1 person on the staging tables, and 1 person at the site connecting the 3 panels put together. And typically we do when we're on the site, especially big jobs, what we're going to do is we actually we'll rotate the men. So sometimes you're working by yourself, sometimes you're working on the staging tables. So it does help the back quite a bit. How do we know the depth of GEOHUB to use and the size? Like I said, that's our free evaluations. We don't have any standard tables for the installing or the selecting the GEOHUB because every single project is different. You're always going to have different soils, different loadings. So we don't have special tables. At least we don't publish them. Like I said, if it's 100 square feet, we'll provide the same evaluation as if it's 1 million square feet. So like I said, please use that request for project evaluation, and we'll give you the size, whether it's a 20, 30, or 40 feet, and then cell depth ranging from 3 to 12 inches. Can you use sand? How can you use sand for infill? Oh, so like I said, when we invented this material with the Army Corps of Engineers, it was called Sand Grid. It was developed for getting heavy vehicles from ships on the beach sands and letting those trucks go over the beach sand without rutting. During Desert Storm, the government used tens of millions of square feet of GEOHUB to build sand roads across the desert so our vehicles didn't get stuck. There's actually a couple of really good case studies if you go to our website, or if you want the case studies, I can send them to you. There's some really good case studies using sand. I would say most of our port projects, at least half of them, are with sand infill. Especially in Florida and southern states, it's very expensive to get quality egress. We do a lot of work down in South America. It's the same thing. Egress are extremely expensive, so we've been using a lot of coarse sands with great success over the last 30 years. So I guess there's no more questions. So I guess once again, thanks a lot. My contact information is here. If you have any questions, please reach out. Thanks again and have a great day.